This video is about vectors in 2 dimensions and how to carry out operations on vectors and solve geometric problems. So let's first go through the definition of a vector. So first of all, a vector is a geometric object with both magnitude and direction, e.g. velocity, acceleration, displacement. So it is not variables such as speed, distance, time, because they do not take direction as well. A vector is also a directed line segment. E.g., you can have a line going from A to B, labeled as little a. A vector is also what is needed to carry point A to point B. So an example of this is when a mosquito is called a disease vector because it's carrying malaria from one person to another. Okay, so that's the definition of a vector. Okay, and there's some other facts that you need to know about vectors that I'll go through. So 2 vectors are the same if both magnitude and direction of both vectors are equal. So something like if I have an arrow that's pointing this way, which is labeled as 2a, then another arrow pointing in the same direction, labeled 2a, is the same. 2 vectors are parallel if they have the same or opposite direction. E.g., if I have an arrow pointing in this direction, which is 2a, and if it's pointing in the same direction, but it's labeled a, then it's also parallel. But if it's in the opposite direction and labeled minus 4a, that is still parallel, because all of them have a's, but they're all different scalar multiples of a, so they're all parallel. What effect does multiplying a vector by -1 have? It reverses the direction of the vector. Can we add vectors? Yes, and how can we represent adding vectors geometrically? So if I know this arrow is labeled as A and this arrow is labeled as B, then A plus B is the same thing as starting off the start of A and ending up here, B. A plus B. Because it's the same thing as starting from here and going to labeled sides A plus B. Can we subtract vectors? Yes. Can we represent this geometrically? If this is A and this is B, then if I label this arrow, will be the same thing as going in B in the opposite direction, so minus B plus A. So that would be A minus B, which is equal to minus B plus A. What is the resultant vector? It's a sum or result of all of the vectors. What is a scalar? It's a constant, has no dimension. What happens geometrically when you multiply a vector by a scalar? It multiplies the magnitude of the vector by the value of the scalar. Last but not least, what happens geometrically when you multiply a vector by a negative scalar? Is it reverses the direction. Because it's negative, it reverses the direction and then multiplies the magnitude of the vector by the value of the scalar. Okay, so now that we have all the knowledge in front of us, we want to apply this knowledge to geometric problems. So let's go through some questions. So question 1. In a triangle ABC, A to B is equal to A. So A to B is equal to A. A to C is equal to B. P is the midpoint of AB, so it's 1 to 1. And Q divides A to C in the ratio, let me use a different color for this part, so it's 1 to 1. And Q divides A to C in the ratio 3 to 2. Write in terms of A and B, B to C. So B to C is the same thing as going from B to A plus A to C. Now B to A is in the opposite direction of A to B, so it's going to be minus A. A to C is just B. So it's minus A plus B. A to P. A to P is half of A to B, which is half of A. C. A to Q is equal to 3/5, because it's 3 out of 5 altogether, 3/5 of A to C, which is equal to 3/5 of B. And D is P to Q is equal to P to A plus A to Q. P to A is the same direction as A, so it's going to be half A plus A to Q we already worked out in part C, so it's 3/5 B. Okay, it's P to A is in the opposite direction of A to B, so it should be minus a half A. So minus a half A. A is equal to minus a half A. Next question is, state with a reason whether each of these vectors is parallel to the vector A minus 3B. So if I look at 2A minus 6B, it can be written as 2 lots of A minus 3B. Therefore, a scalar multiple of A minus 3B, therefore parallel. Therefore, maybe write a full sentence. 2A minus 6B is parallel to A minus 3B. B, we've got 4A minus 12B can be written as 4 lots of A minus 3B. Therefore, scalar multiple of A minus 3B, therefore parallel. C, A plus 3B cannot be written as cannot be expressed as a scalar multiple of A minus 3B, therefore not parallel. D is 3B minus A is equal to minus 1 times A minus 3B, therefore scalar multiple of A minus 3B, therefore parallel. E is 9B minus 3A is equal to minus 3 times A minus 3B. Therefore, scalar multiple of A minus 3B, therefore parallel. F is, okay, times A by half, but it's not the same thing as timesing minus 3B by half. So that means half A minus 2/3 B cannot be expressed as a scalar multiple of A minus 3B, therefore not parallel. Okay, next question. ABCD is a trapezium with AB parallel to DC. So A, B, C, D. AB is parallel to DC, and DC is equal to 3 lots of AB. M divides DC such that D to M to C is 2 to 1. So M is here, where this part is 2 and that part is 1. A to B is equal to A, so A to B is equal to A, which means DC is 3 lots of AB, so it will be 3 lots of A. So 3 lots of A. And we also know B to C is equal to B. That's my diagram. First question, find A to M. A to M is equal to A to B plus B to C plus C to M. Now A to B is just A, B to C is just B, C to M is a third of 3A. So it's a third times 3A, which is just A. So we end up getting A plus A, which is 2A plus. I made a mistake here, didn't I? Okay, because it's going the opposite direction, so it's going to be minus. So plus a third times minus 3A, because it's going in the opposite direction. So it ends up being, so let's rewrite it. So the first two terms are okay. C to M is a third of minus 3A. So a third of minus 3A. So I end up getting A plus B minus A, which is just equal to B. Pot B. B to D. Now B to D is equal to B to C plus C to D. B to C is just B. C to D is going in the opposite direction of D to A, so it's going to be minus 3A. I prefer it alphabetical order, so I'm just going to write minus 3A plus B. C is M to B. M to B is equal to M to C plus C to B. The M to C is a third of 3A. So a third of 3A. And C to B is minus B, which is equal to A minus B. D is D to A. Now D to A is equal to D to C. So via labeled sides, D to C plus C to B plus B to A. Now D to C is 3A, C to B is minus B, plus B to A is minus A. So we end up getting 2A minus B. The next question, OABC is a parallelogram. O to A is equal to A and O to C is equal to B. The point P divides O to B in the ratio 5 to 3. Find in terms of A and B, first O to B. So O to B is equal to O to A plus A to B. Now the important thing here is this is a parallelogram. So that means A to B will also be B and C to B will also be A. So in the same direction, yeah? So O to A is A and A to B is B. So we end up getting A plus B. O to P. To get from O to P, it's 5 over 8 of O to B. Because there's 5 parts of, obviously, O to P, and altogether there's 8. 5 plus 3 is 8, which is equal to 5 over 8 times our answer from A plus B, which is equal to 5 over 8A plus 5 over 8B. C is A to P. To get from A to P, we're doing A to O plus O to P. A to O is just going in the opposite direction of O to A, so it's going to be minus A. And O to P is our answer from part B, so it's going to be 5 over 8A plus 5 over 8B. Minus A plus 5 over 8A is negative 3 over 8A plus the 5 over 8B. In a triangle ABC, A to B is equal to A. So A to B is equal to A. A to C is equal to B. P is the midpoint of A to B, so that means the ratio is 1 to 1. And Q is the midpoint of A to C, so 1 to 1 again. Write in terms of A and B first. A, part 1, work out B to C. So B to C is just B to A plus A to C. B to A is minus A, and A to C is just B. Part 2 is A to P. A to P will be just half of, this is the midpoint, half of A to B, which is just half of A. Part 3 is A to Q. A to Q again, Q is halfway, so it's half of A to C, which is half of B. Part 4 is P to Q. P to Q is equal to P to A plus A to Q. Now P to A is going the opposite direction, so it's going to be minus a half A. And A to Q we just worked out is plus half of B. Okay, B. Show that PQ is parallel to BC. So P to Q, we've just worked out is minus a half A plus a half B. And B to C, we worked out in part 1 is minus A plus B. Now we need to write B to C in terms of minus a half A. So P to Q minus a half A plus a half times B. So What do we need to do this to make it B to C? We obviously need to times it by 2. If we times it by 2 and expand it, we get the first line, which is 2 lots of P to Q. Since B to C is a scalar multiple of P to Q, BC is parallel to PQ and vice versa. Okay, next question. OABC is a quadrilateral. O to A is equal to A. O to C is equal to 3B. And O to B is equal to A plus 2B. Find in terms of A and B. I first find A to B. So A to B is equal to A to O plus O to B, which is equal to minus A plus A plus 2B, which works out to be 2B. To C to B is equal to C to O plus O to B. C to O is minus 3B because it's going in the opposite direction, and O to B is just plus A plus 2B, which we end up with minus 2A. No, which we end up with minus positive A, and minus 3B plus 2B is just minus B. Okay, part B, show that AB is parallel to OC. So A to B we've already worked out is 2B. O to C is equal to 3B. So we need to somehow write it as 2B times something gives us 3B. 2B times 3 over 2 gives us 2B. So it's the same thing as 3 over 2 times A to B. Since O to C is a scalar multiple of A to B, OC is parallel to AB and vice versa. Okay, OAB is a triangle. O to A is equal to A and O to B is equal to B. The point M divides O to A in the ratio 2 to 1. So 2 here, 1 there. MN is parallel to O to B. So parallel to O to B. Express the vector O to N in terms of A and B. Okay, so if I want to go from O to N, one way I can go from O to N is O to M plus M to N. Now O to M is just 2 over 3, 2/3 of O to A. And M to N is just a scalar multiple. Because MN is parallel to O to B, it's a scalar multiple of O to B. Since MN is parallel to O to B, which means I get 2/3 O to A is just A, 2/3 A, plus lambda times O to B is just B. So I get 2/3 A plus lambda B. That's 1, okay? Another way of going from O to N is going from O to A plus A to N. But O to A is just A, and A to N, because A to N lies on A to B, it's some other scalar multiple of A to B. So let's call that mu, since AN is parallel to A to B. Now we need to work out what A to B would be. So A to B is the same thing as A to O plus O to B. A to O is minus A, and O to B is plus B. That means it's going to be A plus mu times minus A plus B. If we collect the A components together, you end up getting 1 minus mu times A plus mu times B. And that is my 2. So if I equate A's and B's, they end up getting 2/3 must be equal to 1 minus mu. So I end up getting 2/3 must be equal to 1 minus mu. And the second thing I end up getting when I equate the B is lambda must be equal to mu. And lambda is equal to mu. This implies that mu must be equal to 1/3 and lambda must be equal to 1/3. Therefore, O to N must be equal to, using equation 1, 2/3 A plus 1/3 B. That's part A done. For part B, show that A to N to B must be equal to 1 to 2. So A to N is equal to mu lots of A to B. Mu was 1/3. A to B was minus A plus B, which means it's equal to, let's not simplify it, let's leave it in that form. So it's 1/3 times minus A plus B. If I work out now what N to B is, N to B is obviously, because it's 1/3 of minus, this is 1/3 of minus A plus B, which is 1/3 of the whole way, then this must be 2/3 of minus A plus B. So N to B must be equal to 2/3 of minus A plus B. So if I'm doing ratio, A to N to B is the same thing as 1/3 of minus A plus B to 2/3 of minus A plus B, which means the same thing as 1/3 to 2/3. If I want to cancel that, times by 3, I get 1 to 2, which is what I wanted to show. Okay, next question. OABC is a square. M is the midpoint of O to A. So that means it's 1 to 1. Q divides B to C in the ratio 1 to 3. AC and MQ meet at P. If O to A is equal to A, so O to A is equal to A, and O to C is equal to C, this is a square, which means A to B is also equal to C, and C to B is also equal to A. Express OP in terms of A and C. Okay, so we need to find out how to get from O to P. So O to P is the same thing as going from O to M plus M to P. O to M is just half A. But M to P must be a scalar multiple of M to Q, because it lies on M to Q, as P lies on MQ. But we need to work out what M to Q is. M to Q will be the same thing as M to A plus A to B plus B to Q. M to A is just half A to B is just C, and B to Q is 1 out of 4, so it's 1/4 times minus A, because it's going the opposite direction. So half take away 1/4 A gives me 1/4 A plus C. So that means I end up getting, going back to the original question, I've got half A plus lambda times MQ, which is 1/4 A plus C. If I equate if I've collected the A's together and the C's together, I end up getting half plus a quarter lambda times A plus lambda times C. So that is my equation 1. Now, the other way of going from O to P is equal to O to A plus A to P. Now again, O to A is just A, and A to P will be equal to a scalar multiple, let's call it mu, times A to C, since P lies on A to C. So now I need to work out A to C. A to C is just equal to A to O plus O to C. A to O is minus A, and O to C is just C, so just minus A plus C. So going back here, A plus mu lots of minus A plus C. I collect the A's together, I get 1 minus mu times A plus mu times C. So if I equate A and C, I get, first one I get is half plus a quarter lambda. So half plus a quarter lambda must be equal to 1 minus mu. And the second one I get is, if I use a different color, I get lambda is equal to mu. Lambda is equal to mu. Now, if lambda is equal to mu, it means everywhere in the first one, I can replace the mu with lambda. So I end up getting, oops, I don't know if I want to draw it like that. So I've got, let me just rewrite it again. I've also got lambda is equal to mu, which implies I get half plus a quarter lambda is equal to 1 minus lambda. If I collect the lambdas on this side, I get 5 over 4 lambda is equal to a half. So half divided by 5 over 4 lambda is equal to 2 over 5, and mu is also equal to 2 over 5. So what we're trying to find O to P, to go here, which means O to P will be equal to, if I go use the second equation, I get 1 minus mu times A plus mu times C. So it's going to be 1 minus 2 over 5 times A plus 2 over 5 times C, which is equal to 3 over 5A plus 2 over 5C. Part B, show that P divides AC in the ratio 2 to 3. So P divides, so I'm trying to work out, this is 2 and this is 3. So A to P, remember is scalar multiple, which is mu times A to C, which was mu times minus A plus C, and mu we just worked out was 2 over 5. So it's 2 over 5 times minus A plus C. Okay, so if that is 2 over 5, then P to C, which is the rest, would be equal to 3 over 5 times minus A plus C. So that means AP to PC will be 2 over 5 to 3 over 5, which is 2 to 3. So it does work out. Okay, last question I'll go through. Figure 7 shows a sketch of triangle OAB. The point C is such that O to C is equal to 2 lots of O to A. So that means I'm going to redraw it here. So because I don't want to write over my working out from my previous question. So O to C is equal to 2 lots, okay? So somewhere here is 2 lots. The point M is such that M is the midpoint of A to B. Somewhere here, M is the midpoint. Let's put 1 to 1. The straight line C and M cuts OB at point N. So if we join it up, then here somewhere it's N. Given that O to A is equal to A, and O to B is equal to B. So if O to A is A, then this part is A to C will also be A because it's 2 lots. The whole thing is 2 lots of O to A. Find C to M in terms of A to B. Find CM in terms of A and B, sorry. So first thing we should do is work out A to B. So A to B is equal to A to O plus O to B, which is equal to minus A plus B. So if I want to work out C to M, it will be equal to C to A plus A to M. But that's just C to A plus half of A to B. C to A is minus A plus half of A to B we just worked out was minus A plus B, which means we end up getting minus 3 over 2A plus a half B. So this is A. B. Show that O to N is equal to 2 minus 3 over 2 lambda A plus half lambda B, where lambda is a scalar, it's constant. Okay, so we're trying to go from O to N. Using what we worked out, it will be equal to O to C plus C to N. But that's just O to C plus a scalar multiple of, because M lies, when it goes through N, it goes through M, it will be a scalar multiple of C to M. O to C is just 2A plus lambda times what I just worked out from part A, which is minus 3 over 2A plus a half B, which gives you 2A minus 3 over 2 lambda A plus half lambda B. If we collect the A's together, we end up getting 2 minus 3 over 2 lambda A plus a half lambda B. Since CMN is a straight line. Okay, so that's part B done. C hence showed that O to N and N to B is equal to 2 to 1. Now O to N is parallel to O to B as N lies on O to B. Therefore, coefficient of A must be equal to 0 because it must, O to B is just B. So that means the 2 minus 3 over 2 lambda, therefore 2 minus 3 over 2 lambda must be equal to 0, which means 3 over 2 lambda is equal to 2, and 3 lambda is equal to 4, so lambda is equal to 4 over 3. So O to N will be equal to half lambda B, which is equal to half times 4 over 3 times B, which is, times just right, half times 4 over 3B, which is equal to 2/3 of B. So O to N is equal to 2/3 of B, which means if this is 2/3 of B, then N to B must be equal to 1/3 of B, since it has to add up to give you B. So O to N to B is equal to 2/3 B to a thirds b, which is the same thing as 2 to 1, which is what we're trying to prove.